Hi Math 30s. This video is going to be the first lesson in our new unit, which is called Exponential and Logarithmic Functions. And this video is going to be on lesson 1, which is on page 159. One of the things I just sort of want to mention before we start this lesson is what the first part of this lesson is going to be on is reviewing the exponent laws. You were first introduced to the exponent laws in Math 10C. Actually, you were even introduced to it earlier in Math 9. But in Math 10C, you spent an entire chapter on the exponent laws. In 30-1, we are spending one lesson on all of those laws from 10C, and then there's a couple additional things I'm going to teach you in this lesson. So all of that knowledge from 10C, we will review quickly in this video, but you do have to know all of it in order to be successful with dealing with exponents. Okay, so just to go through the exponent laws that you're introduced to in 10C, we have something called the product law. When two bases are the same, what we do, and they're being multiplied, we will add the exponents. So product law dictates that we add the exponents. So you just keep your base exactly as is, and we would take the exponents and we would add the two together. The quotient law is when you have two bases that are the same and they're being divided, we subtract the exponents. Power of a power, when you have x to the power of m, and that is raised to the power of an n, that would be power to a power, you multiply the exponents. So it would be m times n. Product, power of a product, we take out the m, and we place it on the x, and we place it on the y. So this would be x to the m times y to the m. I want to show you a mistake that students commonly make with this law. Inside the bracket, it has to be a product, so x times y. Students will sometimes be given x plus y to the power of m, and they will make a mistake that's a Math 10C mistake. They'll take this m and they'll say, can I not distribute it onto the x and onto the y? And the answer is no, you are not able to do that. We can only do this law of distributing if you have a product inside. So for example, let's just say that this was to the power of 2. You cannot take that 2 and put it on the x, put it on the y. What this means, if we have more than one term in our bracket, is I must write that bracket twice. So that would be x plus y times x plus y. And from here, if you were to simplify this, you would do that by the distributive property or by foiling, right? Take this x, multiply it by everything in the second bracket. Take that y, multiply it by everything in the second bracket. Power of a quotient is to take that exponent and put it on the numerator and on the denominator. Okay, the integral exponent and the rational exponent, and actually let's write the zero exponent. So zero exponent. So the first thing we'll do is let's talk about the zero exponent. So from 10C, you're introduced to the zero exponent. Anything to the power of 0 is equal to 1. The exception is if I said, what would negative a to the power of 0 be equal to? So some students want to look at this and they want to say the answer is 1. It is not. This negative 1, or this negative is a negative 1. So this is negative 1 times a to the 0. That would be negative 1 times anything to the power of 0 is 1, but your answer would be negative 1. So if you're making study guides for this, that would go on your study guide. Negative a to the power of 0 is negative 1 would go on your study guide, and here's the math behind it. Okay, so this was called the zero exponent. The integral exponent. What the integral exponent is, it basically is the negative exponent. How do we deal with negative exponents? So in math, we would never submit an answer with a negative exponent. So if I gave you a to the negative 2, you would say, okay, I need to get rid of that negative 2. If you bring this down into the denominator, that negative 2 will become positive 2. That's how you get rid of the negative exponent. It works in reverse if I gave you, let's say, a cubed over b to the negative 4, the negative exponent is in the denominator. So if you wrote that up in the numerator, it would become positive. And then I should write the a first. So this would be equal to a to the 3, b to the 4. Okay, the rational exponent. A rational number is a fraction. So we don't give our answer in with fractions. So what that means is we are going to convert this to a radical. And in 10C, if you were in my class, I would have taught you something called flower power. So what flower power is we're going to take this x, which is our base, and we're going to put it underneath a radical sign. So that x goes underneath the radical sign. And then I always said, this is your ground, right? And what grows below ground? Roots. So the root of this is n, and we always put roots where our index goes. What grows above ground is flowers, but there's no such thing as flowers in math, so this would be the power. So it's x to the power of m. How you would read this is the nth root of x to the power of m. The other way that you could write this is the nth root of x, and then put that in a bracket, and you can put the power outside. And again, it's read the exact same way, the nth root of x to the power of m. So let's do some class examples. And class example 1, 2, and 3, you should have no difficulties with this because this is going to be a review of 10C, right? So if you're struggling with this, you're struggling with concepts from 10C. I'm going to rewrite this one. This is really 1 times y to the negative 6 over 2, right? So they just pulled the 1/2 in front. Here we've got a negative exponent. We must make that positive. It is in the numerator, write it in the denominator. So 1 over 2, and then the y is written to the power of 6. Okay, this exponent is negative. It goes up. This exponent is negative. It goes down. Now, this negative 3 applies to the x. It does not apply to the 5. So the 5 stays exactly where it is because it doesn't have an exponent, a negative exponent on the 5. That's the only way the 5 would move. The x to the negative 3, if I write it in the denominator, it becomes positive. And I'm going to write the y squared up here. And this would be your answer. Okay, 4C. 4 times 2 is 8. This is going to be next our product law. So x and x are like terms. You add those exponents. That would give me 3 plus negative 4 is negative 1. Then y's are considered like terms. Y to the power of 1 times y to the power of 2. That's product law. Add those y's and you get y to the power of 3. We must move that x down to the denominator. So my answer is going to be 8y cubed over x. And I don't need to put x to the 1. Okay, so let's look at this. This is going to be quotient law. 24 divided by negative 4 will give you negative 6. M to the 4 divided by m to the 5, you subtract your exponents. 5 minus 4 is m to the 1, and I don't need to write that invisible 1. Negative 3 minus 2, so I'm just going to write that off to the side. Negative 3 minus 2 would give me negative 5. Q is 4 minus negative 2. When you have two negatives, it becomes a positive. That would be Q to the 6. This is equal to negative 6m. This variable with the negative exponent must go to the denominator, and then Q to the 6 gets to remain where it is. And that would be your answer for this expression simplified. Okay, here is a power to a power. So that 3, remember, there's no additions or subtractions in here, so I could distribute 3 to anywhere in this bracket. Now, a common mistake that students make in 10C, I'll often see on tests, is they will say, they know that the x's, for example, this is power to a power, so they'll get the x's right, and they'll say 2 times 3 is 6. They'll also get the y's right in grade 10. They'll say the y is to the 9. A mistake that I find that students make is with the 3, they will then try to do 3 times 3, and they'll give me an answer of 9 here. That is incorrect. This would be 3 to the power of 3. 3 to the power of 3 is 27. So my answer is 27, x to the 6, y to the 9. Okay, this last one, quotient law. So 12 divided by 3 is 4. And then what I have is I have negative 1/2 minus 1. I'm going to put this over common denominators. So if I got a denominator of 2, this was really over 1, right? So I want a denominator of 2. So I'm going to multiply this by 2, and I'm going to multiply this by 2. And what I will have is negative 1 minus 2, which is negative 3. So this is negative 4b to the negative 3 over 2 is what you would get for this question. That b to the negative 3 over 2, you have to get rid of. You cannot have a negative exponent. Actually, for this one, I want to point out 2 things. We can't have a negative exponent, and we cannot have a fractional exponent. So a couple things need to happen here. One, we need to get rid of the negative first, and then we will get rid of the fraction. So this will be equal to 4 over b to the 3 over 2. That is equivalent to 4 over. My root from flower power is a 2. B to the power of 3. But remember, if it's a root 2, we don't need to write that because the square root of 2, there is an invisible root there or an index of 2. So this would actually be the answer for number 4, or sorry, for F. Okay, let's look at class example 3. So simplify the following, write the answers with positive exponents. Okay, there's 2 different ways we could do this, but I think the easiest way, because this is in a bracket, I'm going to put this over 1. In order to go from a negative 3 to a positive 3, I need to completely rewrite that bracket in the denominator. You do not change anything in the bracket. This law tells me that I could go from a negative 3 to a positive 3 by writing it in the denominator. This stays exactly as is. So in my bracket, I have 4x y to the negative 2, right? So I just write it exactly as I see it. Now I could distribute. That 3 goes on the 4, it goes on the x, and it goes on the y. So that would give me 1 over 4 to the power of 3. So you need to know what 4 to the power of 3 is. And 4 to the power of 3 is 64. X to the power of 3 and y to the power of negative 6. Power to a power, you multiply. This needs to be rewritten in the numerator. So what my answer would be y to the 6 over 64 x to the 3. Okay, if we have a negative exponent but a fraction, what we did in 10C is we said in order to go from a negative 2 to a positive 2, you simply flip this fraction. So 4y squared, or sorry, 4y to the negative 2, we don't change anything, we're just doing our reciprocal, right? We're just flipping this. So 4y to the negative 2 over 3x cubed. From here, that 2 goes everywhere in this bracket. Okay, 4 squared is 16 times y to the negative 4. 3 squared is 9 times x power to a power multiply x to the 6. 16 over 9. Hopefully you see that this must be written in the denominator. So the answer would be 16 over 9, x to the 6, y to the 4. Okay, let's do this one. Without using a calculator, determine the exact value of the following. Verify with a calculator. So 2 to the power of negative 3, I know is equivalent to 1 over 2 to the 3. I know that 2 to the power of 3 is 8, right? 2 times 2 times 2. So that answer would be 1 over 8. We don't need to verify. If you wanted to verify how you would do that, we could enter negative exponents on our calculator, and then we could math one fraction it. Okay, 81 to the 3/4. That is a rational exponent, and we don't deal with rational exponents. We convert them to radicals. So this is the equivalent to the 4th root of 81 to the power of 3. Now, I wouldn't expect you to be able to do that in your head, like 81 to the power of 3 and then taking the 4th root of that. So we could type that in our calculators. How you do that is number 4, math, number 5, 81 to the power of 3, and you get 27 as an answer. (25 to the power of 0 is equal to 1. Remember, if I gave you this, negative 25 to the power of 0, and I said, what is that? You would say, okay, this is a negative 1 times 25 to the power of 0. 25 to the power of 0 is 1 times negative 1. This would be negative 1. 16 to the negative 1/2, we get rid of our negative first by saying 1 over 16 to the 1/2. Then we get rid of our rational exponent. So we're going to convert this to a radical. And according to flower power, it is the square root, and I don't need to write that invisible 2. 16 to the power of 1, I don't need to write that. This would be 1 over 4. Square root of 16 is 4. If you were working from home, what I would do is I would pause this video and I would do questions 1 to 3. When you're done questions 1 to 3, you could unpause and we will do something called changing base. Okay, so let's look at changing base. So this is new. You wouldn't have done this in Math 20-1 or Math 10C. So I'd like you to highlight changing base. So everything up to this point has been a review of 10C. Nothing was new. These questions you should have 0 issues with. This is going to be new. Okay, convert each of the following to the base indicated. So changing base is going to be something really big with exponents and logs. So what they want me to do is, this is a base 9, and they want me to write it to a base 3. So what you have to say to yourself, I'm going to put this 2x outside of the bracket. You have to say to yourself, 3 to what power will give you 9? And everybody should know that that's 3 to the power of 2, right? Because 3 to the power of 0 is 1, 3 to the power of 1 is 3, 3 to the power of 2 is 9, 3 to the power of 3 is 27. So they want 9 converted to base 3. This is how we would do it. From here, we go back to 10C, and we are just going to simplify. So power to a power, you multiply. 2 times 2x would be 3 to the 4x. Okay, 125, that's the base. They want it written in base 5. So again, I'm going to take a bracket, and this exponent is going to go outside of my bracket. Inside the bracket, I'm going to say 5 to what power gives me 125? 5 squared is 25. 5 to the power of 3 is 125. This is then power to a power, which means we have to multiply. But because this is more than one term, you must enter this in a bracket. It is going to be 3 times 2, and then 3 times negative x. This answer would be 5 to the power of 6 minus 3x. C. Convert each of these to base 2. So I'm going to show you something really interesting, and this will come in handy, this little trick, when you get to bigger numbers. We want to convert this to base 2. So I want everybody to take your calculators out, and I want you to go to y is equal to. Type in 2 to the power of x. And then I just want you to hit second function table, which is your graph. What this is showing you is 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 squared is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. So me showing you this table, we need to know 2 to what power is 8 and 2 to what power is 16. So what I'm going to do is I'm going to put this, we need to convert this 8 to base 2, and we need to convert this 16 to base 2. I'm going to put that x on the outside. Okay, let's figure out 2 to what power gives me 8. So if I go back to that table, there's my 8. 2 to the power of 3 gives me 8. There's a 16. 2 to the power of 4 gives me 16. So how do I get that 8? 2 to the power of 3 gives me 8. 2 to the power of 4 gives me 16. I converted both of these to base 2. This is power to a power, I must multiply. So I have 2 to the power of 3 times 2 to the power of 4x. This is now product law, which states that you must add your exponents. 2 to the power of 3 plus 4x would be your answer. Okay, look at this. This is where it's going to be really helpful to see that calculator. So on here, this is 1 over. I need to get 512 to be base 2. So 2 to what power is going to give me 512? Outside of the bracket, I'm going to put this 3x. Okay, so let's look at our calculator. 2 to what power gives me 512, and it's right here. 2 to the power of 9. So instead of guessing and checking, I'm able to do this. 2 to the power of 9. Okay, what would we do from here? Power to power, you multiply. 9 times 3x is 2 to the power of 27x. And then what they want is they want it in base 2. Right now, this is really 1/2. So what I'm going to do is I'm going to bring my 2 up to the numerator. And remember, as soon as you bring your 2 up, this 27x, this exponent is going to change signs and it's going to become negative. So that would be 2 to the negative 27x is your answer, right? If you don't understand that, if I had 1 over b to the power of 5, if the b is positive and I move it up to the numerator, it becomes b to the negative 5. That's the reasoning. Okay, 16 over 81, base 2/3. So what I have to do is I have to say to myself, 2 to the power of what will give me 16, and 3 to the power of what will give me 81. So let's do 2/3. 2 to the power of what will give me 16. So I've already got the 2 on my calculator. And 2 to the power of 4 will give me 16. So I'm going to put a 4 here. And let's now type in on our y1 3 to the power of x. And I'll show you something. So let's go to y is equal to, let's change this to base 3. Let's go to second function table. We were looking for 81. 3 to the power of 4 is 81. So that's why I could put the 4 on the outside of the bracket, because 2 to the power of 4 gives you 16. 3 to the power of 4 gives you 81. So now I converted this to base 2/3. Now what I need to do is I need to put this in a bracket, because outside I have to have x plus 5. Power to a power says you must multiply. This 4 gets multiplied into the bracket. We will have 2/3 to the power of 4x plus 20. Again, pause the video, do questions 4 and 5. Once those questions are done and they're marked, then you can continue on with the video where we will do the last class example. Okay, finishing off with this last class example, I want to show you what we did in 10C and then a better sort of method in 30-1. So solving equations with rational exponents. So first of all, let's look at something we would have done in 10C. If I would have said to you, or 10C or 20-1, so let's just write 10C. Okay, let's say I said x to the power of 3 is equal to 125. And I said in 10C solve for x. You would have said, okay, I need to get rid of the power of 3. So the opposite of cubing something is cube rooting something. So you would have cube rooted both sides of this equation, and you would have gotten x is equal to the cube root of 125. And then you would have said, okay, the cube root of 125 is equal to 5. That's how you would have done this in 10C. In 30-1, what I'm going to show you is there's an alternate way that we could do this. And you might not like it at first, but I'll show you where it becomes very valuable. So I'm going to give you that exact same question. X to the power of 3 is equal to 125. Okay, the way you could have done this in 30-1 is I could have said, we need to get rid of this 3. What can I multiply this by in order to get a 1 here? And the answer is the reciprocal of this fraction. So if I said I want you to get a 1 here because I want to solve for x, right? I want x to the power of 1. So how you would have done that is you would have said, I'm going to multiply this side by 1/3, and what you do to one side, you do to the other side, 1/3. 3 times 1/3 will just give you x. 125 to the power of 1/3 is going to be the third root of 125. And that, again, is equal to 5. So you might say to me, okay, Mrs. King, like, why would we do this when I understand this? And I'd say, okay, that's true, right? This is nice and easy. But what would you do if I gave you x to the 2/3 is equal to 48, let's say? And I said, solve this for me. How would you get rid of this? The easiest way to do this is to get rid of this 2/3, multiply this side by 3/2 and this side by 3/2. You then have x is equal to this square root, we don't need that 2, of 48 to the power of 3. And then you could punch that into your calculator. Okay, so it's really helpful when we see the next example if you understand this concept. And by far, students that try to do this are going to mess up things once they get complex. If they can follow this way, they will get the last question right. Okay, so following that method, what I just showed you, it says solve for x in the following. X to the negative 4/3 is equal to 81. We must, so let's write this out. X to the negative 4/3 is equal to 81. We've got to get this x isolated. You have to get rid of this negative 4/3. What can you times negative 4/3 by to get rid of to get a 1 here. And if you take the reciprocal of this and you multiply it by -3/4, both sides by -3/4, this will cancel. It will become 1. We will get x is equal to 81 to the -3/4. Get rid of your negative first. 1 over 81 to the 3/4. And from here, get rid of your rational exponent. 1 over the 4th root of 81 to the power of 3. Okay? The 4th root of 81 to the power of 3 is 27. So x is equal to 1 over 27. So again, I wouldn't type in this whole fraction. I would just type this in on your calculator. What is the 4th root of 81 to the power of 3? It's 27. Okay, so this answer is 1 over 27. Let's do the exact same method over here. So we need to solve for x. We need to isolate this x. Before we could say, oh, I'm going to add 5 to both sides of the equation, we have to get rid of this exponent. So how you would get rid of a 3/2 is multiply this side by 2/3 and multiply this side by 2/3. We then have 3x minus 5 is equal to, this would be the 3rd root of 27 squared. 3x minus 5 is equal to, the 3rd root of 27 squared is 9. Okay, we need to solve for x, get rid of that 5, add 5 to both sides. 3x is equal to 14. Divide both sides by 3, and we are going to have x is equal to 14 over 3. From here, you should be able to do all 9 questions now in the homework, so I want you to finish up all of that. Students tend to find questions 7 and 8 more complicated, but those are exponent laws right from grade 10. And those of you that are watching the podcast, you want to watch lesson 5.3 part A. It's 11 minutes and 20 seconds. And that concludes the video for lesson 1.